Hello everyone, my name is Arvind Bassan and I am a senior cloud engineer for Oracle Cloud Infrastructure. In this video, we are implementing Palo Alto VM series firewall in HA mode on OCI. Let's look at the safe harbor statement. Look at the agenda below. First, we will understand Palo Alto VM series HA cluster mode. Next, we will design the architecture on OCI, and then we will move to OCI console and proceed with step-by-step implementation. Here we have two Palo Alto firewalls. Left side we have untrust interfaces. There we have primary and secondary floating IP addresses. The secondary floating IP address is a common IP address for both the interfaces, so that if first firewall goes down, it will automatically fail over to the secondary one. And same goes with the trust interfaces. Plus we have management interfaces that comes by default when we provision the firewall. We have two HA links. The first one is for control link and the second for data link. You can also use management interface for control link, but for demo purpose, I have created separate HA links. Next, we are designing the architecture on OCI. First, we have created a VCN of /16 on an OCI region. Then we have created 4 separate subnets for each interface. First is the untrust subnet for the untrust traffic like internet or on-premises. Next, trust subnet for internal communication. Next, management subnet for firewall deployment and configuration. And the last one is HA subnet for HA links and synchronization. Let's move to the OCI console and proceed with step-by-step implementation. We have logged into the OCI console. First, we will create VCN and required subnets. Click Create VCN. Give a name. CIDR block for the VCN. Click Create VCN. VCN has been created. Now we will create 4 subnets for management, untrust, trust, and HA. The management and untrust will be a public subnet as we want to access it from the internet, whereas trust and HA are private subnet as they do not need to connect it from the internet. Let's create the management subnet first. Give a name management. Enter the CIDR block. It's a public subnet. Click Create Subnet. Management subnet has been provisioned. Similarly, we will create for untrust, trust, and HA. Give a name untrust. Enter the CIDR block for the untrust. It's a public subnet. Click Create. Next, we will create trust subnet. Give a name. Enter the CIDR block for trust subnet. It's a private subnet. Select private subnet. Click Create Subnet. Next, HA subnet. Give a name HA. CIDR block for HA subnet. It's a private subnet. Click Create Subnet. All the 4 subnets have been created. Next, we will create Internet Gateway. Give a name. Click Create Internet Gateway. Now we will create a separate route table for public subnets. Give a name for it. Add route rules. Select Internet Gateway. Select the Internet Gateway we created. Quad 0 for the internet access. Click Create. Public route table has been created. Now we will associate it with public subnets. We will associate the public route table with management and untrust interface. Edit, select public route table, click Save Changes. Similarly for untrust subnet, edit, select public route table, save changes. For demo purpose, we will allow all the IPs and protocols in the common security list. Click Security List, Select default security list. Click add ingress, quad 0, all protocols, add ingress rules. So far, we have created VCN, all the required subnets, associated the required route table and security list. Next, we will provision Palo Alto VMs in management subnet. Go to the compute, click instances. Click create instance. Give a name, select compartment, select AD, select the image, partner's image. For this demo, I'm selecting this image. Selecting the latest software, click select image. Next, select the shape. Select 4 OCPUs and 16 GB of memory. Select shape. Select the VCN and management subnet. Paste the keys, click create instance. Palo Alto VM1 is getting provisioned. Meanwhile, we will provision the second VM. Click create instance. Give a name. This time I am selecting AD2. Selecting the same image. Select image and same shape. Select the VCN and management subnet. Paste the keys. Click create image. Palo Alto VM2 has also been created. Now we will start creating VNICs in the respective subnets. Attached VNICs, create VNIC, give a name untrust, select our VCN, select the subnet. Since this VNIC has to forward the traffic, therefore we have to skip source and destination check. Click Save Changes. Next, we will create VNIC for trust interface. Give a name, select the VCN, select the subnet. Since this VNIC also needs to forward the traffic, therefore we are selecting skip source and destination check. Save changes. Next, we will create a VNIC for HA interface. Give a name HA1. Select the VCN. Select the subnet. Save changes. Next, a VNIC for HA2. Select VCN, HA subnet, save changes. We can see all the VNICs have been created in their respective subnets. Now we will assign secondary floating IP address to untrust and trust interface. Go to the untrust interface, select IP addresses, assign secondary IP address, select reserved public IP, create a new, select Oracle so that it will pick an IP address from a pool. Click assign. Similarly, we will do it for trust interface. Click trust interface. Click IP version 4 addresses. Click assign secondary IP address. Since it's a private subnet, so we do not need public IP address, we can directly go ahead and click assign. So far, we have created VNICs for Palo Alto VM1 and also assigned secondary IP addresses to untrust and trust interface. Now we will repeat the same process for Palo Alto VM2. You can see we have created the same for Palo Alto VM2. Next, we will log into these instances and set the admin password. We have SSH to Palo Alto VM1. Now we will set its admin password. Commit. It is done. Exit. Now we will do the same for Palo Alto VM2. We have logged into Palo Alto VM2. Let's set the admin password. Commit. Let's give it a minute. It's done as well. We have logged into Palo Alto VMs. The first interface is ETH1/1. We will assign the name and IPs in the same sequence as we followed on OCI. The first interface is untrust. Interface type is layer 3 IPv4. Here we will enter the secondary IP address, which is a floating IP address which will fail over to the secondary firewall when firewall 1 goes down. Click OK. Next is trust interface. Give a name. Layer 3. Add IPv4. Here also we will assign the secondary floating IP address. Click OK. The next interface is HA1. Interface type, select HA. Click OK. Next interface is HA2. Give a name. Select interface type HA. Click OK. Next, commit changes. Commit. It's done. Now we will log into Palo Alto VM2 and assign the interfaces. We have logged into Palo Alto VM2. Now we will assign the interfaces, but we will not assign the IP addresses because we are using floating IP addresses. It means when firewall 1 goes down, it will automatically fail over to the secondary firewall. Let's assign the interfaces. First ETH1/1. Give it a name, untrust. Interface type layer 3. Click OK. Next ETH1/2. Give it a name, trust. Interface type layer 3. Click OK. Next ETH1/3. Give it a name, HA1. Interface type HA. Click OK. ETH1/4. Give it a name, HA2. Interface type HA. Click OK. It is done. Let's commit the configuration. Click commit. Give it a minute. Configuration committed successfully. We can close the window. The interfaces has been configured. Next, we will set the MTU size. By default, the MTU size on the interfaces is set to 1500. You can change it to 9000 for jumbo frames. Click Device, Session tab. You can see here the global MTU is 1500. You can change it to 9000 for jumbo frames. Click Edit. Enable jumbo frame. Click OK. Click Yes. It is done. Let's do the same for Palo Alto VM2. Device, Session, Edit, Enable jumbo frame. Click OK. Click Yes. Next, we will set up HA. Click on High Availability. Under HA pair settings, click Edit Setup. Enable HA. Enter the group ID, let's say 20. Enter the peer HA1 IP address, which means Palo Alto VM2 HA1 IP address. Click OK. Next, election setting. Default device priority is 100. You can select preemptive so that the highest priority will take the precedence. Click OK. Next, click on HA Communications. Under Control Links, click Edit HA1. Select the interface for HA1, which is ETH1/3. Enter the IP address and the net mask. Click OK. Next, under Data Links, click Edit HA2. Select the interface, which is ETH1/4. Enter the IP address and the net mask. In transport, select UDP. Click OK. HA configuration for Palo Alto VM1 is completed. Let's commit. Click Commit. The configuration committed successfully. Click Close. HA configuration for Palo Alto VM1 is completed. We will repeat the same process for Palo Alto VM2. We have logged into Palo Alto VM2. Click on High Availability. First, HA peer setting, edit setup. Enable HA. Enter the group ID, that is 20. Enable config sync. Enter the peer HA1 IP address, that is Palo Alto VM1 HA1 IP address. Click OK. Next, election settings. Give it a least priority and select preemptive as we have configured the same on Palo Alto VM1. Next, click on HA communications. Under control links, edit HA1. Select the interface for HA1, that is ETH1/3. Enter the IP address and the net mask. Click OK. Next, in data links, click HA2. Select the port for HA2, that is ETH1/4. Enter the IP address and the net mask. In transport, select UDP. Click OK. The HA configuration for Palo Alto VM2 is also completed. Let's commit. Click Commit. The configuration committed successfully. Click Close. The HA configuration on both the firewalls have been completed. Let's look at the dashboard and see the status. I'm on Palo Alto Firewall 1. Click the dashboard. You can see HA1 and HA2 are up. Also, my local device is active, whereas the peer is passive. It is not synchronized yet. Let's look at the status on Palo Alto VM2. I'm on Palo Alto VM2. Click on Dashboard. If you see here also, HA1 and HA2 are up, and this local machine is passive, whereas the peer is active. Here also it is not synchronized. Let's click Sync to Peer to synchronize both the devices. Click Yes. The status has been changed to synchronization in progress. Now I'm on Palo Alto VM1. Let's click the same here. Click Yes. If you look at the status, it is synchronized. Let's check the status on Palo Alto 2. If you look at here, this is also synchronized. It means we have successfully done the configuration of HA in both the devices. The next step is to configure OCI to work in conjunction with the Palo Alto VMs to move the floating IP from one VM to another when it detects an issue. The Palo Alto interacts with OCI APIs and uses instance principles to move the floating IP. The Palo Alto uses the management interface to make the API calls. Therefore, we have to create dynamic group for two VMs and then create a policy to allow the dynamic group to move the IP from one VM to another. Let's move to the OCI console and create dynamic group. Click on Identity, click Dynamic Groups. Click Create Dynamic Group. Give it a name, description, click Rule Builder on right hand side. Click the drop down, select any of the following. Select Instance OCID. Enter the OCID of the first instance. Click Additional Line. Enter the OCID of second VM. Click Add Rule. Click Create. Next, we will create IAM policies which will allow the dynamic group to move the floating IP from one instance to another. Click Identity and Security. Click Policies. Click Create Policy. Give a name. Give it a description. Click Show Manual Editor. Enter the policy. Here I'm allowing the dynamic group to use virtual network family and instance family in the tenancy. Click Create. As of now, we are almost done with the HA configuration on Palo Alto and OCI, but for the testing, we have to enable ping in the untrust interface. Go to the network, interfaces, click on the ETH1/1, that is untrust interface. Click Advanced, select Management Profile, click New Management Profile. The management profile will allow the traffic to terminate in the interface, otherwise it will drop the packet. give a name, select ping, click add IP address, quad 0 for the internet, click OK, click OK. Next, we will create a route, click on the virtual router, click default, select the interface, ETH1/1, that's our untrust interface. Select static route, click add, give a name default, destination quad 0 for internet. Select the interface. Here we have to enter the first IP of untrust subnet. Click OK, OK. Next, and the last thing is we have to add this interface to a security zone for the communication. Click on the interface, select security zone, create a new security zone, give a name, select the interface, ETH1/1, click OK. Press commit to save the configuration. Commit, give it a minute. The configuration committed successfully and we can see that ETH1 is added to untrust security zone. Now we are good for the testing. Let's start the testing. It's the untrust VNIC of Palo Alto VM1 and here are the floating IP addresses. And this side we have untrust VNIC of Palo Alto VM2 where we do not have floating IP address at this point of time. We will start continuous ping to this floating IP address and shut down the primary device, and then we will see how HA works. Let's start the continuous ping. I'm stopping the Palo Alto VM1. We can see the floating IP addresses have automatically moved to Palo Alto VM2 and ping started working. And this is how we have implemented Palo Alto VM series in HA mode on OCI and tested the high availability. I hope the session has been informative. Thank you so much.